Misuses of statistics generally fall into two categories: people, intent on the part of dishonest people. Evil intent on the part of dishonest people. Some people just mean to mislead you. Other people don't mean to do harm, but they just make mistakes. We need to be able to distinguish between statistical conclusions that are likely to be valid and those that are seriously flawed, either flawed purposefully by dishonest people or not on purpose by folks who just don't know any better. Let's look at some examples of flawed statistics or inappropriate conclusions to draw from data. Consider these complaints about airlines published in the U.S. News and World Report on February 5th, 2001. It looks like United Airlines tops the list of most complaints with 252 complaints. Continental Airlines was at the very, no, I'm sorry, Alaska Airlines was at the very bottom of the list, the fewest complaints, only 13 complaints. Therefore, can you say that Alaska Airlines customers are much, much happier than United Airlines customers? Well, not really. You need to think about how many people flew United in the year 2000 or November 2000 versus how many flew Alaska Airlines. If there were only 14 people who flew on Alaska Airlines and 13 of them complained, that would be a much higher complaint rate than United had, even though they had 252 complaints. Probably thousands of people flew United during November 2000. So you never need to look at raw numbers. You need to look at percentages, the percentage of passengers who complained on United and on Alaska Airlines. If we look at percentages, well, it turns out that United Airlines still did have the highest percentage, but Alaska Airlines actually had a higher percentage of complaints than Southwest Airlines. Southwest Airlines on the previous slide had more complaints, but it was a lower percentage of their customers complaining. So always look at percents rather than raw numbers. It's a little more fun going through these examples with a class of live students instead of in my office by myself. It's kind of strange answering my own questions, but I guess that's just what we have to do in a web course. You see if you can answer the question before I do. Researchers found that gun owners are 2.7 times more likely to be murdered than non-owners. Does this mean it's safer to not have guns in the house? This could be used as an argument for gun control. If gun owners are over 2.5 times more likely to be murdered than non-owners, then maybe it's just not safe to have guns in the house. Unless there's a reason that gun owners are more likely to be murdered other than the innate danger of a gun. Maybe there's some other reason gun owners are more likely to be murdered. Maybe it's not that they own a gun that's causing them more likely to be murdered. Maybe it's the fact that they live in a really, really bad neighborhood. Maybe they own a gun because they live in a bad neighborhood, and it's the bad neighborhood that is increasing their chances of getting murdered, not the mere ownership of a gun. So in hot button topics like gun control, when one study is being claimed to make or support a certain claim, you need to ask, is the data really supporting the claim? Just the fact that gun owners are 2.5 times more likely to get murdered doesn't mean that owning the gun is what's getting them murdered. It could be where they live causes them to own a gun, and where they live also causes them more likely to be murdered. Other sad topics. drunk driving. If we look at this pie chart that shows the proportion of people injured in New York City while driving a vehicle, it looks like many, many more, maybe three times as many people were injured when the driver was sober rather than the small piece of the pie, which represents people of proportion of people who were injured where the driver was under the influence or intoxicated. Just looking at this graph, it looks like um, driving drunk maybe three times safer than driving sober. Surely that can't be right. Once again, don't look at raw numbers, look at percentages. There are many, many, many more sober drivers on the road than there are drunk drivers. So just by sheer volume, you would expect more of the people to be more of the people who are hurt to be sober because there are many, many more times sober people on the road. Don't look at raw numbers, look at percentages. The Associated Press provided an article with the headline ATV accidents kill 704 people in 2004. The article noted that this is a new record high and compares it to 617 ATV deaths in the preceding year. Other data about the frequency of injuries were included. What important value was not included? Well, at first glance, I might say the number of ATV deaths is increasing at a rate of about 87 people a year. Heck, if 87 more people per year are going to die than the previous year, maybe we need to outlaw ATVs altogether. But what was not included, at least in this article, was how many people there were driving ATVs. If 5,000 more people were driving ATVs in 2004 than the previous year, and yet only an additional 87 were injured, well, you would expect more to be injured if there were more ATVs out in the woods. So, once again, an example of raw numbers rather than the percentages. You need to look at the percentage of people who were injured or killed in ATV accidents, not the raw number. All right, let's continue in section 1.2. We've talked about the key parts of a statistical study, all the things that we have to consider. Now we need to talk about potential pitfalls in analyzing data. There are a lot of things that can go wrong in statistical studies. One of the biggest is thinking that just because two things are related, one is causing the other. That's certainly not always true. Two variables may seem linked, such as smoking and pulse rate. This relationship is called correlation. One cannot necessarily conclude, though, that one factor causes the other. One of the most important sentences in statistics: correlation does not imply causality. Just because there seems to be a relationship between two things doesn't mean one is causing the other. This is easy to see in the family circus cartoon I'm showing. The guy says, I wish they didn't turn on the seatbelt sign so much. Every time they do, it gets bumpy. Well, that's true. Every time an airline pilot turns on a seatbelt sign, it does get bumpy. But it's not the seatbelt sign coming on that makes it get bumpy. There's an underlying factor. It's the bad weather that's causing the sign to come on and causing the bumpiness. So just because there's a relationship between the light coming on and the bumpiness doesn't mean the light coming on is causing the bumpiness. Correlation does not imply causality. Here's another example. Look at the graph. It shows that there is a relationship between ice cream sales and the murder rate. It appears that as ice cream sales go up, the murder rate also goes up. Maybe this increase in ice cream sales is causing the increase in murder rate. If you want to bring the murder rate down, just stop selling ice cream. That doesn't make sense at all. But there's an underlying factor that causes both ice cream sales and the murder rate to increase. You might know it from a sociology or psychology course, but the murder rate goes up with temperature. More murders in the summer than in the winter. Ice cream sales also go up with the temperature. So there's a definite relationship between those two variables, but certainly in this case, one is not causing the other. We have some examples where we're supposed to use critical thinking to develop an alternative or correct conclusion. Someone noticed that sleeping with one's shoes on is strongly correlated with waking up with a headache. I don't know if that's true or not, but if it is, would it be correct to assume that sleeping with one's shoes on causes a headache? It's more likely to cause a footache, but perhaps there's something, some common factor that would make someone more likely to fall asleep with their shoes on and more likely to wake up with a headache. Can you think of what that common factor would be? I think it could be alcohol or being drunk. Cause you to fall asleep with your shoes on and could also cause you to wake up with a headache. The second example is more realistic. In a widely studied sample, numerous epidemiological studies showed that women who were taking combined hormone replacement therapy also had a lower than average incidence of coronary heart disease. So, for a while, doctors thought we should um, prescribe hormone replacement therapy to reduce women's risk of coronary heart disease because there seems to be a relationship there. But it turns out that there was another factor that um, was an underlying reason that women who were taking hormone replacement therapy had lower risk of heart disease, and that was socioeconomic status. Women who had the means, women who had insurance or the money to pay a doctor for hormone replacement therapy, also had access to other factors that decreased their risk of heart disease, such as gym memberships and healthier foods and a healthier lifestyle in general. So it wasn't the hormone replacement therapy that was lowering their risk of heart disease. It was the fact that women in a higher socioeconomic status were more likely to have access to hormones and things that lowered their risk of heart disease. Other potential pitfalls of data: self-reported adults. If you're surveying people on the street about their weight or their income, sensitive subjects, your data is likely not to be accurate. Self reported data is often not accurate. It's better to bring the subjects into a place where you can weigh them and record those results, or to look at tax returns to get income, not just ask people for information about sensitive subjects. Small samples can be a problem. You wouldn't want to base your prediction on percent of students who um, have to stay for after school detention. You wouldn't want to use as a sample the three dudes who are smoking in the back of the school. They are more likely to have to stay after school for detention than your average student. We're talking high school here, but You can't just use a few people that are close by and handy and make generalizations about the population on those few people. Non response can be a problem. You have to, when you have people who decline to participate in a survey or they don't send back their census results, sometimes that says something. Well, that skews the statistics because that's a certain type of person who wouldn't respond to the survey. You've got to ask yourself, um, how does that affect the data? Precise numbers can give us a clue that perhaps these numbers aren't valid. If something is reported as 23.42% of people believe in, say, heaven, well, you need to question those results just based on the fact that they're given so precisely. They could have been made up on the spot. And then bad sampling methods. We've already talked about voluntary response or self selected sampling methods. They're less reliable because respondents decide whether or not to be included and may have a strong opinion about the issue being studied. Again, you may um, just post a survey on the internet and say, click here to participate in the study. You've seen those thousands of times on the internet. You don't click there unless it's an issue that you're interested in. And so the people who do click there may not have the same opinion about the issue as your average person. Watch out for bad sampling methods. A couple of examples to determine whether sampling method appears to be sound or is flawed. In a survey of 109 subjects, each was asked to indicate how many text messages they send and receive each day. The sample consisted of those who chose to respond to the request posted on the StatCrunch website. These 109 subjects may send more text messages than your average person simply because they were found on a website, which already makes them more prone to be kind of techie. It was a math website, which may mean that they're more techie. Um, it's just more likely that those folks would send lots of messages than someone who wasn't on the internet at all. Your sample needs to include more variety in its members than just people you found on a website and people who chose to respond to your survey request. So that method would be flawed because it's voluntary response. Number two, in a survey of beliefs about evolution, Gallup pollsters randomly selected and telephoned 1,800 adults in the U.S. Well, it says that they were randomly selected. We're going to try to make a prediction about the beliefs of evolution of adults in the US, and 1,018 adults were randomly selected. That is a sound way to do a study. Use a random number generator to choose your participants, or find a way to make sure that your sample is representative of the population. You have to watch out for loaded questions. Sometimes the very way that a question is worded can affect the outcomes of the study. For example, if you approach someone and say, do you think too little money is being spent on welfare? Welfare, the very word welfare, has a negative connotation, and you would probably get fewer people saying too little money is being spent on welfare than if you worded the question Do you think too little money is being spent on assistance to the poor? Assistance to the poor sounds like a better thing than welfare. So, in this particular study, only 19% said too little is being spent on welfare, 63% said too little is being spent on assistance to the poor. It's the way the question is asked and the connotations of the words welfare and assistance to the poor. Watch out for order of questions. Sometimes the order in which the choices are given affects the outcome of the data. A survey was conducted. The question was asked, which would you say contributes more to air pollution, traffic or industry? And 45% of the people surveyed said traffic, 27% said industry. However, when the same question was asked, with the order reversed, industry given before traffic, 57% chose industry and only 24% chose traffic. That's why you also have to be careful on ballots when voting. The person listed first always has an advantage. Most folks, if they don't care who is the city dog catcher, they will choose, are more likely to choose the first person on the list. So the order of the questions can definitely affect the outcome of the study. You have to consider missing data. The U.S. Census Service suffers from missing people. You can't mail a census form to a homeless person. They don't have an address to send it to, so they're not included in the census, and that causes the data to be skewed. Be wary of self-interest studies where people have money to gain from the results of the study. Determine whether the given source has the potential to create a bias in a statistical study. Number one, data set 1 in Appendix B includes body measurements obtained by the U.S. Department of Health and Human Services, the National Center for Health Statistics. That should be unbiased data. The U.S. Department of Health and Human Services doesn't get any of its funding based on what body measurements they include. They're not going to gain from this study, so they have no incentive to report the data incorrectly. Whereas, in number two, an article in the Journal of Nutrition noted that chocolate is rich in flavonoids. Regular consumption of foods rich in flavonoids may reduce the risk of coronary heart disease. That's saying chocolate is good for your heart, and it may be. But if that study was funded by Mars, the maker of all Mars candy bars, then the data is suspect. It may be biased because Mars stood to gain a lot from convincing people that chocolate was good for their heart. All right, last thing I want to mention, let's talk for a minute about percentages. Watch out for misuse of percentages. For example, misleading or unclear percentages are sometimes used. If you saw an ad that says this dental rinse reduces plaque on teeth by 300%, how could that possibly be true? If one use of this dental rinse reduced the amount of plaque on your teeth by 100%, then the plaque's all gone. There is no more plaque. Beyond that, you're probably eating away the enamel of your teeth. Nothing can be reduced by more than 100% because 100% reduction means the quantity is gone.